Students, welcome back to Algebra 1B. Today we're going to be talking about solving quadratic equations by graphing. Now, before we get into the equation solving method, I just want to do some basic review skills to make sure that you know what you're doing before we head into solving. So the first thing is, how do I graph a quadratic equation in standard form? Well, if you remember, standard form of a quadratic equation is y equals ax squared plus bx plus c. So you can see that this equation here, y equals x squared plus 6x minus 3, is a standard form equation. So the first thing that I want to do is I want to find the axis of symmetry. Remember, that is the line that cuts the parabola in half. The formula for axis of symmetry is x equals negative b divided by 2a, or in this case, negative 6 divided by 2 times 1, which turns into negative 6 divided by 2, which turns into negative 3, meaning that we have a line right here that's going to cut our parabola directly in half. Now, step 2 is we want to use the axis of symmetry to find the vertex being the turning point of the parabola. So in order to find that, I'm going to plug the axis of symmetry value back into my original equation. So I'm going to get y is equal to negative 3 squared plus 6 times negative 3 minus 3. So negative 3 squared would be 9. 6 times negative 3 would be negative 18. Minus 3 would be negative 9 minus 18 is negative 9. Minus 3 is negative 12. So that means my vertex is at the point negative 3, negative 12. So my graph only goes down to negative 10, so I'm going to have to go ahead and draw some lines in here. So here's negative 10, negative 11, negative 12. Okay, so step 3 is going to be graph the parent function. And then I'm going to put a second little mark here with the vertical stretch. Now, the reason I put that little mark there is because the vertical stretch is the a value, and in this case there is no vertical stretch, so it's just going to be the parent function. So remember, starting at the vertex, the parent function is going to go right 1 and up 1, right 2 and up 4, 1, 2, 3, 4, and then it's going to go right 3 and up 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm just going to mirror that on the other side because that's what the axis of symmetry does. And then I'm going to connect those dots, and that is the graph of y equals x squared plus 6x minus 3. Now, another thing is graphing a constant function. This is a very easy skill, but one that people tend to forget. So how do I graph this line y equals 5? Well, what that's saying is that when I have a point that I draw, x goes here and y goes here. What y equals 5 is it's the line where y is always 5. So think of any number for x, like 0. If x is 0, y is 5. If x is 1, y is 5. If x is 2, y is 5. If I graph those points, I can see what it's going to look like. 0, 1, 2, 3, 4, 5. 1, 1, 2, 3, 4, 5. 2, 1, 2, 3, 4, 5. And after 3 points, I get the picture. It's going to be a constant function. It's just going to go left and right through that line. So let's do it again. What if I said y equals negative 3? Well, that would be 0, negative 3. 1, negative 3, 2, negative 3. Graphing those would be 0, negative 3, 1, negative 3, 2, negative 3. We get the point. So it would look like that. Now, graphing a linear function, we have to remember that the equation for a linear function is y equals mx plus b, where m is the slope, which we remember is rise over run. And then b is the y-intercept, which is the starting point, 0, and then whatever that b is right there. So in this case, the b is the starting point, would be 0, 5. So we would start off at the y-intercept, 0, 1, 1, 2, 3, 4, 5. That would be my first point. And then I would use the slope, 2 over 3, rise 2 would go up 2, and then run 3 would be right 3. So from my y-intercept, I would go up 2 and right 3, and then again up 2 and right 3. Since the line goes on forever in both directions, I can go backwards, so it would go down 2 and left 3. And then I can do this forever and ever and ever, but instead I'm just going to connect the dots and put arrows to show that it goes on forever and ever. And that is how you graph a linear function. So now moving on, we're going to solve x squared plus 2x equals 3 by graphing. So the way we solve this by graphing, one of the first things you should notice is that in all the graphs that we've done before, there's been a y equals. This one does not have a y, so we're going to go ahead and add the y in. So basically what we're going to do is make two equations, one for the left side of the equation and one for the right side of the equation. So the left side of the equation, I'm just going to say y equals x squared plus 2x. And then for the right side of the equation, I'm going to say y equals 3. So let me move this over here so I can start graphing. Step 1, find the axis of symmetry because this is a quadratic. X equals -2 over 2 times b would be -2 over +2 is -1. So the axis of symmetry is here at -1. I'm going to go ahead and plug that in order to find the vertex. So that means I'm going to go y is equal to -1 squared plus 2 times -1. -1 squared is +1 minus 2 is -1. That means my vertex is at -1, -1. Next step, I'm going to graph the parent function, which means starting from my vertex, I'm going to go right 1 and up 1, right 2 and up 1, 2, 3, 4, and then I can mirror it. Let me go ahead and do that third point. 4, 5, 6, 7, 8, 9. And there is my parabola. Okay, now for the second part, I've got this line right here, y equals 3. That is a constant function, which means y is always 3. So I've got these points 0, 3, 1, 3, 2, 3, and then see where it goes from there. If I graph those, 0, 1, 2, 3 is right here. And I can see that the line is going to be right here. Now the solution to my equation is going to be wherever these cross. So if I start looking for their intersections, I see there's an intersection here at 1, 3, and there's another intersection over here at 1, 2, 3, -3, 3. So I have these two solutions, 1, 3, and -3, 3. Now what we need to remember is that the first number is x and the second number is y in each of these points. However, if I go back to my equation, I notice that I don't have any y's in this equation. I only have x's. The y I made up just so I could graph it, so that means that these numbers right here are actually not a part of my solution because I just made up the y so I could graph it. So that means my solution is x could be 1 or x could be -3. And if you're feeling saucy, you can say x equals 1, -3, and put those in squiggly brackets. Remember, the squiggly brackets mean it's one variable with multiple solutions. Now, let's try another one. Solve x squared minus 8x minus 16 by graphing. Now, here's one. I want to show you a slightly different method. This one is entirely personal preference. So just like last time, I could graph y equals, I'm just going to put a y equals in front of this, x squared minus 8x, and I could graph y equals -16. However, a lot of us are used to graphing in standard form, which has an a, b, and a c, and it equals 0. So what we could do, instead of graphing y equals -16, and honestly, looking at this graph, the graph only goes down to -10, so that means I'm going to have to draw a bunch of extra lines. What I could do here instead is I could add 16 to both sides before I graph, which would give me x squared minus 8x plus 16 is equal to 0. So now I can graph the left side is y equals x squared minus 8x plus 16, and then the right side is y equals 0. Y equals 0 is a really easy one to graph because it's just the x-axis. Look at that, I'm halfway done. Now for the left side, I would go axis of symmetry, x equals -b over 2a. So that would be 4, 1, 2, 3, 4. There's the axis of symmetry. Plugging it in to find the vertex, I would get y equals 4 squared minus 8 times 4 plus 16. So that would be 16 minus 32 plus 16. Well, 16 minus 32 is -16 plus 16 is 0, which means that my vertex is 4, 0, right here. And now I'm going to go ahead and graph the parent graph on top of it, which seems a little bit unnecessary because I can already see the intersection. The interesting thing here is that it only has one intersection. So that means there's only one solution. Remember, the y doesn't exist in this problem. I made it up so I could graph it. So my answer is x is equal to 4. Single solution. Okay, let's do one more. I'm going to go ahead and revert back to my first method for this one. I'm going to graph y equals -x squared, and then I'm going to graph y equals 2x plus 4. Now again, I could add x squared on both sides, or I could subtract 2x and subtract 4 on both sides to get one side to equal 0, and that's entirely a personal preference. Now for this one, axis of symmetry is x equals -b over 2a. In this case, there is no b, so that means b is 0. So I would get x equals -0 over 2 times -1, which would be 0. So I get this line right here. Plugging that in, I would get y equals -0 squared, which is also 0. So my vertex is at 0. Now in this case, I actually do have a vertical stretch. Well, it's a negative, so that means it's going to be a vertical reflection. That means it's going to flip it upside down because there's the negative there. So I get this graph right here. Now, For the second one, this is a linear function. So that means that this one is going to start at 0, 4. That's the y-intercept. 1, 2, 3, 4. And then we're going to use the slope, which is 2. I want this to be a fraction, so I'm going to make it 2 over 1. That means I'm going to rise 2 and run 1. So I'm going to rise 2 and run 1, rise 2, run 1. I'm going to go backwards, down 2 and left 1, down 2 and left 1. And what I'm noticing here is that if I connect the dots, making sure that I go on infinitely in both directions, these actually don't ever intersect. I could continue both the green line and the pink line on forever, and they would never ever intersect. So when I do this, if I try to solve and this happens, the answer is no real solution.